All right, so everything that you've been learning up until this point has been trying to figure out whether the line of regression between two random variables is going to be suitable for use in prediction. So, what is prediction? Prediction is a reasonable guess about an outcome given a specific input. So a line of regression provides a reasonable guess between the relationship of an independent variable, okay, which would be your x value, and the dependent variable, which is your y value. In a previous example with the correlation between third exam and final exam scores, a few estimates were calculated. So using the line of regression, let me scroll down a little bit. Too much. Okay, so if x was equal to 68, so if x was equal to 68, we could plug that into our line of regression, and the y hat value would be 155. If we put x is equal to 73, so if we put the value 73 into x here in our line of regression equation, then what we would get out is that y is equal to 179. So these estimations are predictions. They're predictions because we don't actually have values at those values of x at 68 and 73. Okay. So in this third exam versus final score example, the minimum x value was 65. Let me use a different color here. So the minimum x value was 65, which was there, and the maximum x value was 75, which was this one. Remember that the range of x is the maximum minus the minimum. So if you take this maximum amount and you subtract from it this minimum amount, then this distance between these two is the range. Now, there's two kinds of prediction that you can do. You can do an interpolated prediction or an extrapolated prediction. And the difference between these two is based on whether the value of x that is chosen, if it's within the range of x or outside the range of x. So if you're trying to predict a value of y based on a value of x, if the value of x that you've chosen is within the range, we call that interpolation. So here's another graph of the scatter plot and the line of regression, but here you can see that I've expanded the graph. Instead of having like a minimum of 65 and a maximum of 75, I expanded the maximum on the graph to 90 and the minimum to 50 to kind of create some more space. So if we were to choose a value of x that was within the range, so anything between 65 and 75, then this would be what's called an interpolated prediction. So if we put in, like a value of 74, and this is where if we put x equals 74, we're going to end up getting a value of y, that's considered an interpolated prediction. But if the value of x that we put in instead was something that was above the maximum or below the minimum, then that would be an extrapolated prediction. Okay, either above or below. And so doing extrapolated predictions is very dangerous because you don't truly know if this linear pattern that you have data for if that continues to exist outside of where you actually have data, either above or below. Okay, you really don't know if that is still true. So earlier, when we chose values 68 and 73, these were both within the range of x, right? 68 and 73 were like here and here. So those were both within this range of x. So those were considered interpolated predictions. But if values of x were chosen outside the range of x, like 57, which would be somewhere right about here, or 79, which would be somewhere right about there, then the resulting values of y would be called extrapolated predictions. Okay, so if we took a value of 57, went up to the line of regression and went over, then maybe the value of y we would get would be maybe around 90. That would be an extrapolated prediction. If we put in a value of 79, so we'd go up from 79 until we hit the line of regression and come on over. That looks like that would give us a score of maybe 200, maybe a little over 200. That again would be an extrapolated prediction. So interpolated predictions are generally considered to be safe predictions because one is working within the space of experience. Okay, so let me talk about what I mean by the space of experience. So between the minimum and the maximum value, this is our space of experience right here. We've collected data for values of x between 65 and 75. So what the line of regression is modeling that data that we have, those values of x that we've collected data on. But extrapolated predictions are generally considered to be risky because one is working outside the space of experience, okay, outside the range of the data that is collected. So, let's take the third exam versus the final exam scores, for example. So first, the highest score possible on the third exam was an 80. The highest score recorded for a student was 75. And the highest score possible on the final is 200. So the highest score possible on the third exam is an 80, and the highest score possible on the final is 200. If one tries to do an extrapolated prediction, so an extrapolated prediction where x is equal to 80. Okay, so before we continue, let's kind of look at what we're talking about here. So here is our range of experience between 75 and 65. This is our range. This is our range of experience. So by choosing a value of 80, we're choosing a value that is outside our range of data. And so this value of 80, x being equal to 80, this is going to be an extrapolated prediction. And I think what you can see is that if someone had gotten a perfect score on the third exam and we're trying to figure out what score would they get on the final, well, if we follow this line of regression to do a prediction, we're going to end up with a final score that's higher than the total number of points. And that's not possible. All right, but to kind of show that a little bit more explicitly, if we take our line of regression and we plug in 80 for x right here, so here's that 80, and we simplify this expression, we get 212.682, which means therefore, if a student got an 80 on the third exam, then their final score, when you come over here, is going to be 213. So the question is, how is a predicted score of 213 possible when the maximum score on the final is 200. So what we've done is we've used this line of regression in a risky way, and it produced a prediction that is invalid, that isn't possible. Okay. So whenever you're trying to extrapolate predictions, you have to be very careful about how you're doing it and why you're doing it. That's why it's generally considered to be safe, to do interpolated predictions within the X values of your range of your data. And then as another example, so part B, if we chose a value of 36, so if a student scored a 36 on the third exam, so on the third exam, they scored a 36, then y would be equal to 0, a 0% on the final. So if a student, for example, got 36 out of 80, like a 45% on the third exam, doesn't that indicate that the student knows something? So isn't it unlikely then that a student would get a 0 on the final? I mean, so the final we're presuming here is cumulative. It's over everything over the semester. And if on a third exam they got some points right, they got 36 out of 80 points, wouldn't they maybe get some of the questions on the final correct too? They would get something and it wouldn't be 0. But if we use this line of regression, then at a value of X or a value of the third exam on 36, that would mean a predicted score on the final of 0. So again, we're working outside here in this extrapolated prediction, and it's very risky and it can cause some significant problems when you try to use it. So the real danger with lines of regression is assuming the two variables are always linearly related. So maybe between X equals 65 and 75, the third exam and the final exam scores are linearly related. But below 65 and above 75, maybe not. There are ways to factor in increasing margin of error when making extrapolating predictions, but that is beyond the scope of this class. Okay, so let's stop here. Let me know if you have any questions.